I've had a personal interest in energy efficient, low maintenance homes for years, and after I moved up here from Atlanta, I got involved with developing a timber truss kit to market to builders, as you can see. A partner and I, a young builder, decided to do an Energy Star house up here because we saw a trend with baby boomers buying weekend homes and then converting to full-time. And we were seeing them retire and over a period of time having maintenance energy issues. So we took one of my standard floor plans and adapted it to meet the Energy Star ratings, EPA national level. We use my hybrid timber frame trusses. We use a very high grade foam insulation continuous panel. We use spray foam on the 2x6 walls, and of course the foundation requirements of Energy Star. Energy Star, of course, is a certified program by the EPA and sets down some pretty strict requirements, but not only just in general energy, in the grade of the windows, appliances, also in particular attention to infiltration. The Energy Star requirements are approximately 1/3 of air exchange per hour. That means the house has to be better than 1/3 of the volume of the house leaking out. This house tested out, Howard from South Base can tell you, came out at 0.05%. So a lot of the techniques we did in here were very important. Also, the other thing that's very important to balance that, with the tight house, you have to have air exchange.
To bring in the fresh air and satisfy that requirement and still be energy efficient, Energy Star recommends using a 4-inch external duct with a controlled damper. As you can see, the LED is red right now. When the air exchanger comes on, the furnace comes on, the air handler, that damper will open up and we bring controlled fresh air into the house only during that time that's cycled on. Small energy loss due to that, but still it's a good compromise.
On this size house, 1550 square feet, 2 bedroom, 2 bath, we didn't necessarily need an ERV, HRV to do the additional recovery, although we recommend it on larger houses. Basically, there's an overhead, and when you bring in the fresh air, you're going to lose energy to get the fresh air in. So if you do a simple damper like we do, you're going to have a slight overhead loss of energy. So on a larger house, you need to add an additional device, either ERV or HRV, energy recovery vehicle, such that when you pull in the air, whether it's a heating and cooling cycle, you exchange the energy you already have in the house and don't lose it to the outside. It's more expensive, but on a larger house, it would be recommended.
That I felt there was a need as I moved up here for a interesting product in the construction industry, timber frame-like, but a little more cost-effective, a little more modular, for example, a building block that builders could use. And I've always been interested in timber frames, and particularly knew that the timber frame handcrafted were very expensive. They were labor-intensive, and I had a manufacturing background, so I started looking at glue lamps. And of course, you can purchase them in architectural premium grade, which you know about, for commercial buildings. So as I evaluated and started studying it, I decided to do a timber truss kit, timber-like, using the glue lamps, which are a renewable product, in reasonable price because of the strength you get. You can use a smaller beam. And wanted to come up with a building block. So the idea was to come up with several different truss sizes that you can mix and match and build kits. And of course, I involved then into doing floor plans to aid the builders because they needed help in doing floor plans, as you know. So this particular project here, the Walnut Mountain Energy Star house, we used 2 different trusses, an 812-26 queen in the great room and a 612-26. Interesting is we're able to get the cost of the truss kit down to several dollars a square foot. If you compare that to timber frames, it's probably half the cost. And I estimate the average roof structure, a ventilated roof, is probably $3 to $4. So in effect, we're fairly cost effective for a premium product. The other thing you get out of it is because of the 2x6 wood roof, you also pick up a stronger structure, which is important, and you're able to use the foam, continuous foam insulation, which is very important for energy efficiency. The main component on the upper part of the house is a hybrid timber truss system, a Cathedral ceiling, what I call Cathedral Ranch, and we use the glue lam kit hybrid timber trusses made in my shop. As you see, we hide the big structural brackets in the wall. But on top of it, we put the tongue and groove 2x6 to span the 6 foot, moisture barrier, double foam layers so we can break the thermal breaks up. On top of that, we use a 5/8 CDX plywood with the long timber lock screws that go through, and the length is proper that you can torque them down and hold the sheets up there. Around the perimeter, we have 2x8, which is why you get the 7¼ inch, which gives you the R31. And then we use ice and water shield on top the entire roof, in addition to caulking all of the joints with the recommended foam caulking that is by a SIP manufacturer. So they have a pretty good history in sealing. But the ice and water shield we think is real important over the entire roof, rather than just the ice damming requirement you see up in New England. Again, up here in the mountains, we tend to have a lot of water and wind-driven rain. We think it's important to really seal that thing and totally get that house sealed. Again, it showed up in the Energy Star air exchange blower test. Part of the pre-building idea, we pre-built all those T's in the shop, rough cut them, in the headers, and I have the foam cutting tools and a foam cutting table. We pre-built all those in the shop. The headers, people don't realize the headers and the headers are obvious, the T's aren't as obvious. So everywhere you have a T, a junction T, like external T right here, they all have foam in the corners. When you put the whole house together, and all the other little details like the floor trusses and those rim board areas, the spray foam application on not only what you pre-built, but when you finish the complete house, tie all that together and make it less infiltration. So that's a neat thing about the final application, doing it that way. We chose the high density foam to test on this house, and there was another reason. As you notice, because it's a Cathedral ranch on one floor, for weekend purposes, with a migration path for finishing the basement for future guest quarters, etc. Having the high density foam, you could then have enough wall space left to do wiring, any last minute modifications. So that was another reason why the high density foam applied later was important. The client can live up here in the 2-bedroom, 2-bath, and then as they decide to move full time, they can add the guest bathroom, the guest bathroom, bedroom, the den, etc., and then finish that out, the minor electrical, minor additional framing that they would add. I alluded to the frame section, the daylight corners, the non-berm sections, of course, is 2x6 framing with the spray foam, and of course we do the house wrap on the outside. But the berm concrete, and we use 10-inch poured reinforced walls with like a 2-foot square grid here. We want strong structure up here on the mountains. But because of the Energy Star requirement to have R11 around the basement, well, the concrete parts, and my desire to always use the thermal mass of the concrete if you can, we chose a system called Tough and Dry, Warm and Dry, and it's a super high density fiberglass that also protects, it's on the exterior, and it also protects on backfill damage against the waterproofing. And the waterproofing is a flexible rather than the hard, so if you ever have a minor crack in the foundation, a thermal crack, it protects and won't break. So it's a combination of that waterproofing on the concrete with the additional 2 layers of R5. We were able to get close enough to the Energy Star rating of a goal of R11. Still, you can add extra insulation as you finish the interior, depending on how you want to finish the interior of the basement. But the key goal is to get as much insulation practical on that outside foundation for the thermal loss. Plus, I think it's important to pick up the extra waterproofing that you get because of the extra barrier you get.